Good afternoon. I'm Dr. Joseph, and this is Unit 2, Lesson 2, First Derivatives and the Shapes of Graphs. This is the first in a series of videos about what the derivative can tell us about the shape of a graph. So we'll be building on this uh, for a little while. Um, so in this first video, we're just talking about the relationship between the first derivative and the original function. So in blue on the left is a graph of a function f of x. And in green on the right is a graph of its derivative. So this says, where is the first derivative positive or negative? Um, it looks like it's positive coming in from minus infinity until here. Let's make that a different color. That looks like the first time where it actually reaches zero, and then also again at the origin. So f prime x is positive from minus infinity to minus 2, union 0 infinity, and it is negative from minus 2 to 0. So let's mark those exact points on the left here. When x is negative 2, we are at this point, and then the origin is right there. And this is something we've observed before, but we're just trying to make it official today. So when the first derivative is positive, the original function is increasing. It isn't increasing very much, but it looks like it's increasing just barely until we get to this point. And then also again from the origin and forever forwards. And then this tiny little interval from minus 2 to 0, it's decreasing. That corresponds to exactly when the derivative is below the x-axis. Okay, so the sign of the first derivative tells us when f is increasing or decreasing. So this is kind of just that same statement. If we're differentiable over a whole open interval, and if the derivative is positive at every single point of that interval, then f is increasing over the entire interval. And same thing, if it's negative over a whole interval, then f is decreasing over that interval. Um, okay, and here's an example. So they tell us what the derivative of f is and say, find all intervals over which you can guarantee f of x is increasing or decreasing. Um, Okay, so if x cubed e to the x is the derivative, then we're just trying to see where is that positive or negative. Now, useful fact is that e to the x is always positive. You might remember the graph looks like this. It never actually reaches zero, right? So if we're trying to see where is this positive, we really just need to see where is x cubed positive. And x cubed is positive when x is positive. You could think about the graph for that. Or you could take a cube root of both sides. So that's just going to be increasing on 0 infinity, and then this is going to be less than 0 when x cubed is less than 0, which is when x is less than 0. So it's decreasing on minus infinity to 0. Here's a try it yourself problem. Let me suggest another try it yourself, which is to take this and take its derivative and try the same thing on that. Where is f prime of x increasing or decreasing? So for that, you'd need to take the second derivative and see where is that positive or negative. So you'll need the product rule and then see where that is above or below the x-axis. And in this one, it says the derivative is minus ln of x. So you'll have to think about what natural log looks like and then negate it. But here is the answer. And that's all for today. In a lot of these problems, they would give you f of x and you would first have to take its derivative, but they gave us the derivative, so we just have to see where is that positive or negative. All right. Have a good one.